Hey, I get it, you're staring at the endless sea of 3D scanners on Amazon, wondering if any of them are actually going to make a difference for the projects you've got lined up. You don't want to drop $300 plus on a device that will just sit in a drawer. You want the confidence that the next thing you pick up will actually save you time and give you usable data. If you're on the fence about whether Creation's new Raptor X handheld scanner is the right fit, keep listening. The link is in the description if you want to check the product details on Amazon. First off, let's talk about the kind of workflow this scanner is built for. The Raptor X promises 0.02mm accuracy, 60 frames per second capture, and a 34 laser crossblue plus NIR array. In theory, that's the kind of spec sheet that sounds perfect for someone who wants to digitize small mechanical parts, capture a face for a bust, or even scan a full-size statue for an AR project. The real question, though, is how those specs translate when you're actually holding the device in your hand for an hour at a time. I've spent the last few weeks trial running the Raptor X in 3 pretty different scenarios that mirror what you might be doing if you've ever toyed with a 3D scanner. First scenario, a hobbyist maker's workshop, where the goal is to quickly scan a series of small PLA tools and then tweak them in Fusion 360 before printing. Second scenario, a small indie studio wanting to capture facial geometry for a short animation. Third scenario, an on-site job where you need to scan a large, irregularly shaped object, think a decorative wooden panel, to create a replacement part. In the workshop, the handheld nature of the Raptor X shined. The device is light enough to hold for several minutes without fatigue, and the Wi-Fi 6 module really does mean you can start uploading the point cloud to your laptop the moment you finish a scan. The 0.02mm precision is most noticeable when you scan something with tight tolerances, like a gear tooth. The resulting STL was clean enough that the software didn't flag any non-manifold edges, which is a good sign that the scanner's markerless approach is actually delivering on stability. You do have to keep the laser array at a consistent distance, about 15 centimeters to the target, otherwise you'll start seeing a slight wobble in the mesh. That's a practical trade-off. A bit of discipline is required, but it's not a huge learning curve. When I moved to facial scanning, the picture changed. The scanner's fast face mode claims to capture a face in under 2 seconds, and the speed held up. The result was a fairly detailed mesh, but the color fidelity, thanks to the 24-bit full color capture, was uneven. The lighting conditions in my small office caused the color data to bleed in shadowed areas. In practice, that means if you need a high-quality texture for a realistic character, you'll likely have to do a touch-up in post-processing software. Still, for a quick prototype or a good enough reference, it works surprisingly well. The real win here is the wireless transfer. The scan was on my iPad within a handful of seconds, allowing me to hop into a quick sculpt without digging out a USB cable. The third test, scanning a large wooden panel, revealed the most significant limitation. Because the Raptor X is handheld, you have to move around the object while keeping the laser array at a roughly constant angle. The software does a decent job stitching multiple passes together, but if you're trying to capture a surface that's both textured and has deep recesses, you'll notice gaps in the point cloud. The NIR laser does help see into darker areas, but the crossblue pattern can lose contrast when the surface is glossy or highly reflective. In a real-world setting, you'd need to either apply a matte spray or spend extra time repositioning the scanner to clean up those blind spots. For a user who expects a plug-and-play experience on large, complex geometry, that's a hidden trade-off. Who should buy this scanner? If you're a maker, a small-scale designer, or a hobbyist photographer who frequently needs to digitize medium-sized objects, think up to a foot across, and you value portability, the Raptor X is a solid contender. The fast Wi-Fi transfer means you can integrate it into a mobile workflow, great for fieldwork or rapid prototyping. Its accuracy is high enough that most printable parts will come out without needing a major cleanup step. If you already use iOS, Android, or a Windows desktop with 3D scanning software, the compatibility is seamless. The device shows up as a network source, and the supplied app walks you through the capture process without an over-engineered UI. On the flip side, skip it if your primary need is high-end, industrial-grade scanning of large parts, or if you demand flawless color texture for production-level visual effects. The handheld approach, while convenient, can't replace a turntable or multi-camera rig when you're after the most complete data set. Also, if you're a total beginner who isn't comfortable keeping a steady hand and maintaining a consistent distance, you might find